Section 5.6. Here we're going to talk about different types of rational functions. Let's just go through everything that we need to for graphing these functions, and you'll see what makes them different as we start going and seeing the different types. So here, what I'm going to call this is bottom heavy. Notice that the degree in the denominator is higher than the degree in the numerator. So what ends up happening, what I'm looking at, and specifically, is our horizontal asymptote. All of these are going to end up being very, very similar. This one kind of, sort of, but the one that changes the most, depending on the graph, is going to be our horizontal asymptote. So here, let's start with our first part. Our vertical asymptote. So vertical asymptote happens when our denominator, or when our function is undefined. Our function is undefined when the denominator is equal to 0. So let's set our denominator equal to 0 and see where we're at. So x equals -1. This is our vertical asymptote, and we're going to graph this on our graph. So when x is equal to -1, that's a vertical line here going through the point, or going through the x-axis at -1. So x equals -1. That's our vertical asymptote. Next, number 2 is going to be our horizontal asymptote. Our horizontal asymptote is determined by our end behavior. So end behavior for a rational function is going to be in the form of y equals something. And here we're going to grab the leading term from the numerator. In this case, it's 3. And the leading term in the denominator, in this case, x. So notice here, 3 isn't going to change in value, but what does change in value is going to be this denominator. As we plug really big numbers in here, let's look at -6. So 3 over -6, we end up with -1/2. Let's go a little bit further and say 3 over -10. That's -0.3. So a little bit smaller. So our y-axis is getting a little bit closer. And we start plugging in really, really negative numbers. Let's say -100. That ends up being -0.03, which is even closer to 0. So as we start plugging in very, very big numbers, and in this case, it doesn't matter whether it's negative or positive, -0.00003 is just as close to 0 as positive 0.00003. Those are still very, very close to 0. So in this case, what we look at as the end behavior, we're just going to say that it's equal to 0. So we say that our horizontal asymptote in this case is y equals 0, because it doesn't matter how far off we go into negative infinity, we're still not going to cross that 0, or we'll test it in, I believe, number 4 or 5. But we still go closer and closer to 0, but possibly not touching 0. So that's our horizontal asymptote. Oh, I forgot to label this. Vertical asymptote, horizontal asymptote, y equals 0. That's our horizontal asymptote. Now let's go on to number 3, our y-intercept. Our y-intercept happens when x is equal to 0. So we're going to evaluate our function at 0. So f of 0 is equal to 3 over 0 plus 1. 3 over 1, which is just 3. So this gives us the point when x is 0, y is 3. When x is 0, y is 1, 2, 3. And there we go for our y-intercept. Number 4 is our x-intercept. And our x-intercept happens when y is equal to 0. So this time we're going to set our function equal to 0. So we have 3 over x plus 1 equals 0. And to get x by itself, or to remove x from that denominator, I'm going to multiply to both sides. So we end up with those two divide out. 3 is equal to 0 times x plus 1 is still going to be 0. 3 does not equal 0, so we have no solution here. So no solution for the x-intercept. And because we have no solution for the x-intercept, that means we have no x-intercept. Number 5 is, does it cross our horizontal asymptote? So cross our horizontal asymptote. And what we're going to do is grab our horizontal asymptote and set it equal to our function. So horizontal asymptote. Let's get it so we could see both of them. So horizontal asymptote equal to our function. Horizontal asymptote equal to our function. Our horizontal asymptote we mentioned was y equals 0, and our function 3 over x plus 1. Let's move x plus 1 over, or multiply both sides by x plus 1. So 0 times anything is still going to be 0. And these two divided out, so we're left with 3. 3 does not equal 0, which means we have no solution here, which means we don't cross our horizontal asymptote. And now for the tricky part, part number 6, pick more points. So pick more points. What we're looking for is to see where we don't have part of our function. So let's kind of see where our graph is right now. So we know that we're never going to cross that vertical asymptote because that's where our function's undefined. In step number 5, we checked to see if we were going to cross our horizontal asymptote. So we know that we don't cross it anywhere. So we know that that's on its own. So we know that on this side of the graph where we have this one point, our graph has no other choice but to follow the asymptotes. So we just get really, really close. If we go on to infinity, we get really close to that vertical asymptote. Well, actually closer to -1 from the right side, we go to infinity. And as we go to infinity on the right side, we get really, really close to that y equals 0, but never actually cross it. So this part, and part of being a function, is that you pass that vertical line test. You only hit once at every vertical line. So we know that this part of the function, we're not going to have any other values. So what we have to do is test the opposite side of our vertical asymptote. So I'm going to check this side. Here we have x is equal to -1. I'm going to check x equals -2 to see where we're at. If we're above the axis, we know we're not going to cross the horizontal asymptote, so we know we're going to come up this way. If we're below the x-axis or below our horizontal asymptote, we know that our graph is going to do something like that over here. So let's evaluate. That's going to be our pick more points, that -2. So let's come down here and pick more points, evaluating our function at -2. And our function was 3 over x plus 1. So we have x as a -2, then plus 1. 3, that's -1, so we have -3. We have the point when x is -2, y is -3. So we come over here, -2, we have -1, 2, and 3. And there we go. We know that our graph has to do something like this over towards this asymptote, and the graph has to do something like this over at this asymptote. And that's it. So this is graphing a function which I call bottom heavy, where the denominator is larger, a larger degree than the one in the numerator. If you have any questions, please feel free to ask. Otherwise, bye.